Hello everyone. We're solving statics problems. Our topic, two-dimensional force systems. Now we have a problem we've solved before. We'll solve this problem using alternative methods. We previously solved it using the parallelogram rule and the sine law. Decompose the force R in the figure into two components along the A and B axes and find their magnitudes. A force R with a magnitude of 800 Newton is given. It's horizontal and directed to the right. The A-axis makes an angle of 30 degrees with the horizontal. The B-axis makes an angle of 110 degrees, as shown in the figure. A and B are the components of R, R is the resultant. FA and FB are the components. We'll find the magnitudes of these components. Their directions are given. Now, when we solved this problem before, we constructed a parallelogram like this. From the end of the 800 Newton resultant, we drew parallels to A and B to create the parallelogram like this. We drew FA and FB. We drew its shape. And we found FA and FB using the law of sine by considering one of the two triangles that form this parallelogram. Now, I'm going to find it in an alternative way, in two alternative ways. I'm going to find FA and FB. I'm going to find it in terms of the perpendicular components. We'll solve the problem by considering the perpendicular components of the forces. What do I mean? We know the relations Rx equals sigma Fx, Ry equals sigma Fy. What do these relations tell us? The projection of the resultant onto the x-axis is equal to the sum of the projections of the components onto the x-axis. The projection of the resultant onto the y-axis is equal to the sum of the projections of the components onto the y-axis. In fact, where is this x-axis, where is the y-axis? Any direction. It doesn't have to be horizontal or vertical. Any direction. The projection of the resultant onto any direction is equal to the sum of the projections of the components onto that direction. Of course, we need to perform this addition by taking into account the signs originating from the directions. Let's not forget that. Now, we need to choose the x-axis and y-axis. These aren't given in the problem. When choosing these axes, we try to ensure they are as parallel or perpendicular to the forces as possible. Let's do the same here. We don't necessarily have to choose horizontal and vertical as we always do. However, choosing horizontal and vertical seems appropriate here. So, I'll choose horizontal and vertical here as well. I'll make the x-axis coincide with the resultant force of 800 Newton. In other words, whichever force we choose here still makes an angle with the others. Therefore we can make it coincide with only one of them. I'll make it coincide with the resultant force, with R. I'll make the x-axis coincide with the resultant force. I'll choose horizontal and to the right. It's positive to the right. The y-axis is perpendicular to it and positive upwards. Let's choose the axes accordingly. In this case, the force B, FB, makes an angle of 20 degrees with the negative side of the y-axis. Because if that angle is 110 degrees, 90 plus 20 makes 110. More precisely, 110 minus 90 makes 20. That angle is 20 degrees. We see that too. Now let's start writing the equations. Let's obtain an equation from the equation Rx equals sigma Fx. Let's obtain an equation to find the unknowns. Rx equals sigma Fx, so Rx equals Fax plus Fbx. There are two components. We will add their projections on x and set it equal to Rx. Let's write the projection of R on x. We made the force R coincide with the x-axis. Therefore the projection is easily found. It is equal to itself. Its direction is also positive. Since it is to the right, we chose the right side of the x-axis as positive. Therefore, Rx equals 800 Newton. Let's find the x component of Fa. We project the force Fa onto the x-axis. We find the perpendicular projection. Fax is as shown in the figure. The angle between Fa and Fax is 30 degrees. Therefore, Fx is Fa times cosine 30 degree. It is in the positive direction. It is positive. Fx equals Fa times cosine 30 degree. Let's move on to Fb. Let's find its projection onto x. The projection of Fb is also seen in the figure. It is in the negative direction. We know the angle Fb makes with the y-axis. We can also find the angle it makes with the x-axis. But there's no need. We can also write Fbx using these 20 degrees. Fbx is equal to Fb times sine 20. But it is in the negative direction. Therefore, we won't forget to write that minus sign. We will write it ourselves. Because it is also seen in the figure. Fbx is negative. Fbx equals minus Fb sine 20 degree. Yes. Let's write these together. We've obtained one equation. 800 equals Fa cosine 30 minus Fb sine 20. There are two unknowns here. Therefore, we still haven't found what we're looking for from this equation. One equation for two unknowns isn't enough, but we now have one equation for two unknowns. Now, let's look for the second equation. Let's write the second equation. Where do we write it? We'll obtain it from the relationship Ry equals sigma Fy. Let's write the relationship Ry equals sigma Fy. Ry equals Fay plus Fby. We're adding the y components of the forces. Let's write the y component of R. The R force is parallel to the x-axis, so it's perpendicular to the y-axis. Therefore, its projection onto y is 0. Ry is 0. We see from the figure that Ry is 0, perpendicular to the axis. Let's move on to Fa. The y component of the Fa component, its projection onto y, and its projection perpendicular to y, Fay is in the positive direction and is found by multiplying it by sine 30. We see from the figure, 2. The opposite vertical side, the vertical side opposite 30 degrees, is Fay. Therefore, Fay equals Fa times sine 30, positive. Let's move on to Fby. And write the y component of Fb. This, as we see from the figure, is negative. Fby equals minus Fb cosine 20 degree. Yes, we wrote Fby as well. Now let's write it all together. We have our second equation. The left-hand side is 0. 0 equals Fa sine 30, minus Fb cosine 20 degree. This is the second equation. We now have two equations for two unknowns. By solving these equations together, we can find the two unknowns we're looking for. From these two equations, we obtain Fa equals 1170 Newton, Fb equals 622 Newton. We can find this result by solving these equations together. Let's move on to the other alternative. Now, what did we say? Rx equals sigma Fx. We can choose the x-axis as we wish. We said we could choose it arbitrarily. Let's choose an x-axis such that only Fa is included in the obtained relation. Let's not include Fb. Therefore, let's find Fa directly from that equation. We don't need to solve the equations together as we did before. Now, let's do what I suggested. To avoid Fb's inclusion in the equation we'll write, we define an x-axis perpendicular to Fb. I've shown this in the figure. I defined the x-axis as the direction perpendicular to Fb. I chose the positive side of the x-axis to the right so that the force's projections on x are positive. Anyone who wants this can also choose the left side positive, but it doesn't change anything. But choosing this way is more logical, a better idea. Now, let's write Rx equals sigma fx according to this situation. Let's write it according to the x-axis we chose. Rx equals fax plus fbx, fa has a projection, but fb doesn't. Because we chose the x-axis according to it. We tried to avoid fb having a projection. We tried to avoid it. So, fbx became 0. Now, here, we chose the x-axis perpendicular to fb. Therefore, when you subtract 90 degrees from 110 degrees, the angle between the force r and the x-axis is 20 degrees. The projection of r is 800 cosine 20, since the angle between them is 20 degrees. The projection of fa. The angle between them is 30 plus 20, 50 degrees. Fa times cosine 50 degree. In other words, the projection of fa and the projection of r are equal to each other. We see this in the figure. We also see this in the relation we obtained. The projection of fa on this line is equal to the projection of r. Because there is no projection of fb. Yes, from here, we can find fa directly. 800 cosine 20 equals fa times cosine 50, and if we subtract fa from here, we find fa equals 1170 Newton. Let's move on to finding fb. We'll find it in a similar way again. What will we do? Don't include fa in the equation we're going to write. Let's include only fb, and from there, let's find fb directly. So, this time, we'll choose the x-axis perpendicular to fa. We'll make the line perpendicular to the force fa coincide with the x-axis. I chose the x-axis as shown in the figure. I chose the downward side as the positive side. Because the projections of forces onto x are positive, so this is a better idea. Anyone who wants can choose the upward side as positive. It's up to them. In this case, the angle between r and this x-axis is 60 degrees. Because if the x-axis is perpendicular to fa, we can only get 90 degrees by adding 60 degrees to 30 degrees. If the angle between fa and the x-axis is 90 degrees, and the angle between fa and r is also 30 degrees, then this angle is 60 degrees. What remains is 50 degrees if we subtract 60 from 110. The angle on the left below and the angle between fb and the x-axis is also 50 degrees. We see that these are true. Yes. Let's write the relation Rx equals sigma fx according to this choice. Now let's write the projection of Rx, the angle between them, is 60 degrees, cosine is 60, 800 times cosine 60. Fax is 0. Because we chose the x-axis perpendicular to fa. Fbx is fb times cosine 50 degree. So here, the projection of r is equal to the x-component of fb, fa has no x-component. Yes, from here, we can find fb directly. 800 cosine 60 equals fb times cosine 50. We get fb equals 622 Newton. That's it for this problem. Goodbye.